A couple of reminders before we get started on the margin of error is that we have the the mean for the population is written as mu. And then our mean for the sample is written as x bar. We also have the proportion for things. So the proportion for the population is P. Proportion meaning the percentage or how many out of the total. Right? That would be your proportion. So if we have 19% of people that approve of the policies that we have for immigration, that would be the proportion. Okay? If you are doing the proportion from a sample, then we call it P hat, with that looks like a hat on top of the P, and that's the proportion for the sample. So to find your P hat, you take the amount of people or items that are in the outcome that you want out of the total. So when we're looking at these, when we take a sample, what we want to be able to do is find out what the population is for the mean. Okay, let me try again. You need to find the mean for the population from the sample. So you want to know how close is your mean of the sample to the mean of the population. So what we want to be able to do is calculate this margin of error. And then with that margin of error, we can tell how far we are from approximating the actual amount of the mean, or the same thing with the proportion. So we want to find an interval for plausible values for our mean, or an interval for plausible values of our proportion. Okay? Now we have some requirements that we have to meet in order to do this. So we looked the other day at our average temperature for humans, and we went through that activity, and we saw that your margin of error for the mean is 2 times S over N, where S is the standard deviation for the sample. So we also need to remember that S is the standard deviation for the sample, and that sigma is the standard deviation for the population. Okay. But we saw using the central limit theorem that your N has to be at least 30. Okay. We have a similar stipulation that you need for your margin of error for proportion. So these are our two formulas that we're going to be looking at today that we're going to be utilizing. Okay. So the first one is that in order to use the margin of error for means, our sample size has to be at least 30. In order to use our margin of error for the proportion, we need these two statements to be true. So remember, P hat is the proportion of the sample. So if you times that by N, which is the number in the sample, that has to be greater than 10. And then if you do 1 minus the proportion, the P hat, and then times by, that should be an N, that has to be greater than 10 as well. Okay, so let's take a look at a couple of examples. So the number of eggs a female house fly lays during her lifetime is normally distributed. Random samples of size 16 are drawn from this population, and the mean sample is determined to be 800 eggs with a standard deviation of 100 eggs. Find the margin of error for the mean. Find the interval for plausible values for the actual mean. Okay. So if we're looking at this, first of all, we're determining, is it a mean or is it a proportion? So because we want the mean, or we're given information about the mean, okay, we know that we need to use the margin of error for the mean. So we're doing 2 times S over N, the square root of N. Okay. But we need to make sure that our N is greater than or equal to 30. But 16 is not greater than or equal to 30, so we can't use our margin of error. So it's too small for our margin of error. Okay, so it's not applicable for this problem. Okay. So if we look at the next one, random sample sizes of 36 are drawn from the population. The mean of each sample is determined to be 100 eggs with a standard deviation of 100 eggs. Find the margin of error for the mean. So first of all, when we check, our n here is size 36. So since 36 is greater than 30, that means that we can use our formula. So now I want to use our formula. Now, when you get into a further statistics class, there are different ways that you can calculate how confident you are that your actual mean for the population falls between your values. Okay, for our class, we're just going to be using this formula with that 2 out in front. So we're really confident that our values for the mean lie between this number and this number. So if we calculate this, we're going to do 2 times S. Remember that S is the standard deviation for the mean. So, okay, so try again. Standard deviation for the sample is what I was going for. So since our sample has a standard deviation of 100, the S is 100. So we're going to do 2 times S, which is 100, over the square root of n. And our square root of n is 36. So if we go to our calculator, we can do 2 times, and you can do alpha y equals if you would like to here, and then put your 100 divided by the square root of 36. You could do that. Or you could just there we go. Or you could just do 2 and then times by, and then your parentheses, 100 divided by the square root of 36. Or since you know the square root of 36 is 6, you could just simplify that to 6. So we get 33.3. Okay? So if we're going to look at our margin of error, okay, we've got 33.33. Okay. So that means, did I times it by 2? I suddenly can't remember. Yes. Okay. So that means this is our margin of error. So what we're going to do is we're going to take our mean to find our reasonable, I wanted to add this on this one, so we'll just put those instructions like that. So we found the margin of error, but we also want to find the interval for plausible values for the actual mean. So we start with our mean of our sample. So we're going to take our x bar, and then you're going to do plus or minus your margin of error. So if we look at our mean for the sample, we have 800, and then plus or minus 33.33. So that means that on the high end, we have 833.33. And then if we do 800 minus, and then I can just do second answer, that gives us 766.67. So what this number is saying, these numbers are saying, is that we are really confident that the actual mean of eggs that a fly lays during their life is somewhere between 766.67 and 833.33. Right? So since you can't just have a portion of an egg, you could say that we're going from 767 to 833 eggs. So our actual mean for the population, we're really confident that it lies between those two numbers. Okay? Now, we're just going to say really confident. There is a way that you can specify your level of confidence. We're going to save that for a more advanced statistics class that you have. Okay? So we're just going to start that we're really confident that the actual mean lies between those two numbers. Okay? So if we take a look at this next one, you work for a consumer advocate agency and want to find the mean repair cost of washing machine. As part of your study, you randomly select 40 repair costs and find the mean to be $100. From past studies, you assume that the standard deviation for the population is 1750. Find the margin of error for the mean. Okay? So we're going to do 2 times our standard deviation. This should be S, not sigma. So we're going to do 2 times our standard deviation, which is 1750, over the square root of the number that we have. So we selected 40. Now, before I do this, I need to make sure that the number that we're picking has to be greater than 30. And it is, so that means that I can use this formula of 2 times s over the square root of n. Okay? So then if we go to our calculator, we're going to do 2, and then you can do parenthesis, and then 1750 divided by the square root of 40. Depending on your calculator, you may have to close a parenthesis inside your square root and then get out of your root and then close your parenthesis. So you should get 5.533. So then we have, if we want to find the interval for plausible values for the actual mean, that means I'm going to take the mean that we have for our sample and add and subtract our margin of error, and that gives us our plausible values that the actual mean lies between. So we have our mean was $100, and then we're going to add and subtract the 5.533. So that gives us 105.53. And then if we do our 100 minus, and then I can use second answer, that gives us 94.47. I'm going to round to 2 decimals since we're talking about money. So 94.47. So what this means is that we're really confident that the actual mean cost for the population of washing machines is between $94.47 and $105.53. Okay. Now, you can also look at changing your margin of error. Remember how we talked about if you increase your sample size, then your margin error goes down. So if I wanted, if I want less of a margin of error than this 33, I would have to increase the sample size instead of it having being 36, right? So that's another way that you could take care of reducing what your margin of error is. Because sometimes if your margin of error is too wide, it doesn't give you good information, right? So now we're going to look at the same kind of thing, but with proportions instead of margin of errors. So if we look at this one, in 2001, a Gallup poll surveyed 1,016 households in the U.S. about their pets. Of those surveyed, 599 said that they had at least one dog or cat as a pet. Find the margin of error for the proportion. Okay. So first of all, we have to figure out what p hat is. So p hat is the number of outcomes that you want out of the total number of them. So in this case, we had 599 out of the total 1,016 that had a dog or a cat as a pet. So our p hat is 599 divided by 1,016, which gives us 0.5896 when I round. Okay. So when we use this in our calculator, we want to use second answer so we don't end up with a rounding error. Okay. Now, you can store this value into a variable called x. So if at the bottom, because it's the 0.589566 so on, is sitting there at the bottom, above your on button it says STO for store. So I can just hit STO for store, and I want to store that number, and I can use a variable, so I'm going to use x. So from the blue button or the second button, maybe yellow, I'm going to go diagonally down to the right and hit X. So now when I hit X, it's going to use that number. Okay. So before we run this, we have to check that n times p hat is greater than 10, and that n times 1 minus p hat is also greater than 10. Okay. So our n in this case is the number of people in the sample, just like it is previously. So in this case, we had 1,016 in our sample. So if I do 1,016 times by, and then I can use x, or you could type in second answer in this case because that's sitting in your calculator. Both are fine. That gives me 599. If I do 1 minus x, oops, okay, and then I times that by the 1,016, okay, that gives us 417. So basically you want at least, what this is telling you want at least 10 successes and 10 failures. Okay. So we have at least 10 people that have one dog or cat, and at least 10 people that don't have one dog or cat. But that's the mathematics behind that. So because both of these are true, that means that we can then use our equation that is 2 times, and if you remember from up here, it's p hat times 1 minus p hat over n, all in the square root. So p hat times 1 minus p hat all over n. Okay. So now I'm going to check this. Okay. So when we go to put this in, we're plugging in our p hat. So I'm going to do the square root of 0.5896 times 1 minus 0.5896 divided by n, which is the 1,016. Okay. So now I want to put this in my calculator. So to put this in my calculator, I'm going to do 2, and then I'm going to do the square root, and then I'm going to do alpha y equals. If you can't do alpha y equals, you're going to have to put parentheses around the top. So you're going to have to add in an extra set of parentheses here, and then do the divide by the 1,016. So since I stored my x value in here to be the 0.5896, that makes it relatively easy. So I can do x times 1 minus x, and then divided by, and then this case we have 1,016. Okay. So then this gives me 0.030865, so on and so forth. Okay. So this p hat is the same thing as a proportion, which goes to a percentage. So this would equal 58.96% of the people have a cat or a dog as a pet. Okay. So this would be our margin of error. So then the next part is to find the interval for plausible values for the actual proportion. So because we only took a sample, what's a good value that the actual proportion lies between? Okay? So then what I'm going to do is I'm going to take my p hat and I'm going to add and subtract my margin of error to get that interval of plausible values. So I'm going to do 0.5896 plus or minus 0.030865. Okay. So I can do x plus second answer, and then I'm going to have to do x minus, and then 0.030865, and I'm going to go out a little bit of a ways so that I don't get a rounding error. Okay. So that gives me that I'm between 0.5587 and 0.6204. Okay. So the actual percentage of people who own a pet that's a cat, at least one cat or dog that's a pet, is 55.87% to 62.04%. Okay. So we're really confident that the actual proportion of people who own one cat or dog as a pet is somewhere between 55.87% and 62.04%. Okay. Now, again, that margin of error isn't too bad, but if I had something that was like from 30% to 80%, that's not really useful information to me because it's such a wide range. So what I would want to do in order to solve that is I would want to up the sample size so I could lower the margin of error. Okay. So let's take a look at another example. So a study of 562 computers found that 19% of those computers needed repairs or had problems by the time the product was 3 years old. So find the margin of error for the proportion. So we have to find our p-hat. Now this time our p-hat was already given to us as the percent. So our p-hat is 0.19. So if it's given as a percent, you need to change it to a decimal. Okay? We still need to check that n times p hat is greater than or equal to 10, and then n times 1 minus p hat is greater than or equal to 10. So if we look at our values, we can do 19%, and then our amount of computers was a number that I forgot. 562. So times 562, that gives us 106.78 computers were bad by the 3 years or had problems. So then I'm going to do 0.19 times by 1 minus, nope, sorry, wrong one. We're going to do the not 0.562, 562 times by 1 minus 0.19. So 455. So both of those numbers are greater than or equal to 10. Okay? So then that means that I can use our formula, that is 2 times the square root of p hat times 1 minus p hat over n. Okay? Knowing that both of these things are true allows me to be able to use this formula. Okay? So then I'm going to do 2 times, our p hat is 0.19, so 0.19 times 1 minus 0.19 all over n, which in this case is 562. So then I'm going to do 2 times the square root, and then I'm going to do alpha y equals if I can, because it just looks a little bit nicer and is easier to keep track of your fractions. If not, you need to put this whole thing in parentheses. So 0.19 times 1 minus 0.19, and then I can hit down to go to the bottom, and then 562, because that was the number in our sample size. So then this gives us 0.033096. So this would equate to, if we move this over, 3.31% of a margin of error. Okay? So what I can do to find the interval for plausible values for the actual proportion is that I take my p hat and I add and subtract our margin of error. Oops. So the p hat is 0.19. And then I'm going to add and subtract our margin of error. So here I'm doing it as a decimal. If you wanted to do it as a percent, you could do it as a percent as well. So if I do it as a decimal, that's 0.033096. And then if it's a percent, I'm going to do 3.3096. Right? So then here I can do 0.19 plus second answer. So then my max is 22.3. And then if I do 0.1 minus, and then 0.0330964298. So I don't have as much of a rounding error. So I'm going to go from 0.1569 to 0.223, and then I'm going to round to 1. Or that would be the same as 15.69% to 22.31%. Now that's not a bad margin of error to have. It's not a ton of variance, so that's not super worrisome. If I had something like, say we wanted to figure out the approval rating of the president, and we wanted to, and we got that the approval rating was 45% plus or minus 20%, right? So that is going to give me, what did I say, 45 and 20? So that's going to give me 25% and 65%. So between 20 and 65% of the people approve or disapprove, I can't remember which way I said, of the president. And that's too wide of a margin for us to be saying something useful about it, right? So you would want to lower your margin of error by increasing your sample size so that your margin of error gets closer to the actual proportion of people.